And we're back. Apologies for not having the webcam. It seems my computer doesn't want to recognize the webcam right now. I don't feel like messing around with the firewall settings, so just gonna skip that for now. So I guess fortunately or unfortunately, you won't be blessed with my face. It'll instead just be blessed with the good old Solidworks interface. So, for the nobody that joined the first half of this presentation, I hope you enjoyed the really rough sketching section that was so rudely interrupted after the skiing snack break. I guess like driver on my graphics card crashed, which is something I've heard happen. Well, it's kind of a known issue, I guess, with the 5700 XT, the graphics card I have. It's been known to crash occasionally. And that's probably, I want to say, maybe the third time it's crashed on me in the past, like 2 years of owning it. So, hasn't been a huge issue, but definitely happened there. that was bizarre seeing the whole OBS software just blow up, and I guess it was normally I got an error on my actual monitor saying that my display was running at 50 hertz instead of 60 hertz, which is really weird. I don't know how often that happens. I don't know why it would do that, but for whatever reason, it did. Anyway, we are back to working on building this robot. Guess I might as well start with the hardest part, and that is going to be the big base plate. Wish I had the camera now so I could just give you a quick review on what we are making, but I suppose I will have to leave that be, and you will simply have to watch the previous video. Sucks to be you. So anyway, we're just going to adapt this. I'm just going to reuse this adapter here, which I did the same thing with this link and this link. I just reused this link, basically cut out this middle section here and reused it for this, because it had the same servo connection and the same pivot connection, so it worked out well instead of rebuilding this whole configuration, having to rebuild everything. I'm just gonna rebuild this section, and so we have a bunch of unnecessary cuts and planes, and I guess I might as well delete the ones that I can, which might be easier said than done. Cut loft, keep that mirror. How's that cutting there? So how do we want to do this? We don't need that cut loft either. Yeah, actually, no, I don't want to sketch here. I think we're just going to ignore all of that. It's going to make a really gross part, but it'll work. We're just going to convert this face. We wanted to make it was 10 millimeter. So make you 10 millimeters thick. Then we want this bottom piece end up being flat. So let's just cut this section so we know what we're working with. Corner rectangle, go from there to there. Extrude a cut. We'll just through all both. Go with everything. I'll leave us a nice base plate, which I guess didn't convert all the circles on it, which is kind of a pain in the butt. So we will still just nothing. Stop with the notifications. Focus assist. Alarms only. Circle, 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 circles, circle, 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 circle. Why could you? Looks like we're good. Okay. Exit you. Those cuts don't go all the way through, but that is fine. I think. Should be fine. Yeah. I guess we should recut those anyway. I shouldn't have even bothered converting them. Oh well. You. I guess those middle ones are probably fine as is. Convert all these sketches. Missed one. Convert you to sketch. And we'll extrude it cut. We will go up to this surface. And that will allow us. We have the connection for the servo. We have the connection for the big ring around it. Have little bolts to screw into all of those holes. And now, just a front face. Front face is there, top plane's there, right plane is way over there. All right, we're in the middle of nowhere. You, I don't want to see you. You, I don't want to see you. Let's start this side. So we're going to need a nice flat piece on the bottom. Be the easiest way of doing that. I guess I should just adjust. Yeah, I'll just adjust that extrude, edit the sketch. And from these points down, we will make it U. Vertical, U, tangent, U, trim, 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 bam, bam. So leave this still, nice cylindrical face to press up against, but also the flat platform we will need to create this. Do I need to extend that further down? I don't think so. I think I like it as is. So from there, we will sketch on here. Extend you out. Don't like how we're not anywhere near that origin point, but we will move on. You connect it there. You, that plane, coincident. That touches there, that touches there. How far do we need to go? Let's just start with the drawing. See how that goes. Looking at 71 millimeter. So that is to there. Can we get to the outside of that circle? Don't think we can. That circle will be 32 mil radius, 71 minus 32, 39. Distance 39. Get us to there. You and you will be tangent. You will be trimmed. And you will be trimmed. I want to Pre-make any holes in it. Guess we might as well. Let's see. A circle for construction. Our gear was 32 mil across. We don't want to make you for construction. 2 mil. That distance, that was 13.75. Yeah, that'll overlap nicely. Here. Gap to that wall. 1 mil, let's do, right now it's 16, let's go 18. Nice 2 mil gap between the gear and the actual wall there. As far as the hole to cut through. How do we want to do that? I guess we'll just do the width of the bolt we are using, which was 5 mil. Whereas like 4.5 should be good. 4.5 because the bolt is a little over 4 mil. So I'll give us a tight fit, but not an extreme amount of tolerance for it. So it'll be that hole for there. The second one, we'll go somewhere around. So might as well make it out front as about possible. You do use the same bolt. How do you want to attach it? I guess I want to do the same technique. See, I'll do the same bolt work. I just want to use a really small bolt for it. No, I'll keep it like that. And I can tighten the bolts, and that'll be good. Distance-wise, how far apart do you want? 45 is a nice number. This distance, I'll do 5 mil because that's a nice number as well. So that's not going to leave a whole lot of clearance, except those aren't going to sit where we're going to want them to sit flat. How wide do we want our extension pieces? So those are 7.5. So this will be 7.5 minimum. We'll go 8 millimeters. So that if there's a 7.5 mil piece extending off of this gear and a 7.5 millimeter piece extending off of here, they can be perfectly straight and they won't touch each other at all. Make sure that's good. Any other holes to drill through? That's pivot, that's pivot. That gets built up from there. Should be all the holes, and so we will simply take you, mirror about the middle plane, and extrude this. I want to go blind, reverse, 10 mil. Boom. Except the... What am I missing? Why do those holes not work out? Let's sketch. That region. That that's even less than what we want. We don't want that region. So nope. Don't want that region. We just want that. Nope. You know what? Just get out of here. Okay. Sketch 20. Extrude the boss piece. There we go. And boom. It's got the holes for the gears, holes for the front bit. Gear will go around like there. You can put the post for the GoPro right there. Should be good to go. Nobody in chat still. Good to go. All right. Next, that stuff like that. I'll just screw into there. That goes there. That goes there. I guess that. Ooh. Yeah. Okay. So we will want to make. No, we want features. We want a reference plane. It's going to be referring to there. We are going to want this to be flush with the bottom face of our servo when it is flush with the gear. So those are all flush together. We're at 17.36. We'll go 17. I'll just go 18. Give a bit of wiggle room. Servo. There's a bit of play. Yeah, we'll let the servo take up the slack. So we have a 10 millimeter thick gear on the bottom. We have 18 millimeter from. Let's see. Let's just do this. 18 mil from there. So we're looking at 28 millimeter to the bottom of the servo. So that distance. Oh, great, it's backwards. That distance is basically just measuring. We have a different propeller on it, but we're going from the front face of this to this face here, because that's what the servo will be resting on. Doesn't matter which face I go. Doesn't really. Or does it? I think it does. Yeah, it does. Yeah, we'll go with the bottom one. Because you have to make a pivot piece that the GoPro attaches to. And the pivot might require support material if we do it differently. So can I just take you and what? I want you, edit you. Can't I just kind of. Except we have to go with that face. Boom. All right. Now we're good. Cool. Looks fine. Right, from there. No, I don't want here. Back to the link. So we have this plane here. That plane was a top to there, so we have to extrude. I'm just going to extrude big ol' rectangle. Yeah. Or do I get fancy with it right now? Like a big old rectangle and then cut that shape into, no, we'll just make that, yeah. Okay. Big old rectangle, extrude boss base, other direction, want it, let's go, this 4 mil? 4 mil should be fine. So yeah, servo will sit on that, bolts going through this. And now, switch to that view. I guess it doesn't matter. I want to sketch on this face. As far as the servo goes, let's go back. Update you, you're fine. Which is what we want. I want to open up this part. So we can use these dimensions to help line up where that servo is going to go. So on a rectangle, that's 42 by 22. Go here. Rectangle. 42 millimeters wide. I guess 42 long, 22 wide. We're going to get you. Can I click that circle? I guess not. Coincide, and that's not what I want. Guess we'll do this manually. Yeah. So from that dot to that face, 18 millimeters. Then back to here. These circles will all be 4.5 millimeters wide. I'll do the middle rectangle first. So that is 9.87 by 50.28. 9.87 by 50.28. 9.87 by 50.28 for construction. 9.87 by 50.28. Line that up. Of course, I locked you in the middle. Which is use coincident with. Oh, I can't move it. Good old Solidworks. Okay. You vertical. Nicely in the middle. Let's see. So the distance from that side to the center of it is going to be 12.39. So the distance from this line to the center of there, 12.39. Bam. And we want this line there to be horizontal. Okay. That looks very nicely centered. I thought it would be horrendously out of place like this one was. This was a pain to try to get the servo offset correctly so it focused nicely in the center of it. But this one, the offset was already built in. We have a, was it 12.75 mil offset and a 12.39 mil secondary offset. So that was actually worked nicely. So with that like that, we'll make our 4 holes for the bolts. Make those all equal. Smart dimension. Let's go this one. 4.5 wide. Okay. So if we cut through this through that top piece, we'll be able to slot the servo into it. There's little fins on the top of the servo. So we're going to need to make a little cut for those to keep them from being in contact. They are a little over 1.5 millimeters wide, and the entire thing is 6.2 millimeters or so. So easiest way to do this is do a corner rectangle. You there. I'm gonna want you to be 2 millimeters wide. Change this so it's not as cluttered. Here to here. 7 mil to make sure it doesn't contact. Oh, with all those lines, it's gonna be fun. Cut you, 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 and cut you. Okay. Now, oh boy. Let's put some center lines in to hopefully help lock stuff in place. Which I don't think that really did, but oh well. Okay, so we cut that through. Servo will slot in place. Be able to position on the gear. We are then going to cut this in line with this outer section, so everything is nice and even. It's gonna be slightly uneven because this isn't perfectly centered, but it'll look nice to have these sides flush with the bottom section. So with that cutting through, features, extruded cut. You'll cut up to surface. I wish I could switch to up the surface and then move, but it just switches back. Boom. Cut that. And bam. So now we can fit the servo like that. Okay. Go back here, sketch. Exit you. Close you. I didn't make any changes. I don't want changes. I just want you mate. Let's see if the servo actually sits where we want it. Connect you. We want that to be this circle. Switch alignment. Oh boy. And then let's go that face, flush with that face, this face, parallel to that face. Okay. So got the holes nicely lined up. Servo fits nicely. Got a little bit of wiggle room on the outside, which is good. And that is that. I'll have to recut that piece though. Cut extrude. Edit feature. What are you? No. Connect to you. Horizontal. I think that's horizontal. Horizontal enough. It might be slightly off a center, but that'll be fine. That connects to there, that connects to there. That'll sit on there. Do I build some braces for it? Might want to save all. Might be the way to go. Make that to there, that to there. Let's just build the next section first. That servos like that. We are now going to easiest way is probably going to be build the thing in the middle and then figure out how we want to connect it. So, all right. Do we have a plane that sits in the middle? Plane 1. You are in the middle. Nice. I want to sketch on you. Starter, we'll do a circle. You are going to be 15 millimeter wide. Actually, sorry, I'm just going to switch you over to webcam mode just because I don't want you looking through all my files with me. And sorry they don't have the webcam. As I said earlier, it kind of died on me at the crash of last stream, so just wanted to switch it onto there to browse files. So as you saw in the last video, this was the GoPro mount. So right now, no, I don't want that one. I simply want these dimensions. So it's 5.25 and then 15 wide. You will do a little circle in the middle. You'll be 5.25. Then this whole dimension off of, can I not go off that line? Off of this line. What was that? So that was 4.4 to the outside of it, plus 7.5, which will give us to the middle of the circle. So we're looking at 11.9. Circle there. Looks like we're gonna have to cut some of this off, but that is fine. As far as the height of it goes, that is right there. Do this to the top surface of it. 7.5. You'll go 10 millimeters. I think we want it as far down as we can. So let's go 9. It's a very slim margin for error, but that'll be fine. Then I want to build this in the middle. Build it up, and we'll have to build it bigger up top, or we just cut it at the bottom. We'll just cut it at the bottom. Okay. As far as this goes, we want right around here and curve up. Or do I just go straight? straight line. No, we have to printing it from here up. So we're gonna want this, and I guess that's gonna require support. This is gonna require support. But I'd rather not this require support. So let's go. So a line from here to top section's fine. Yeah. Can go boom, boom, boom. I want you tangent. I want you to be horizontal. I want you to be there-ish. I want you to be perpendicular. Distance-wise, I guess we'll go. This thing is going to be 7.5 wide. It's looking at 3.75 the distance. Can I go 5 mil? 5 mil gives some wiggle room. Gives a nice sweeping line up. I think that'll look fine. Then we'll do a second line here. Just go like that. You. Make it 6 mil wide. I want to go 6 mil wide. Why do I want that? Well, 7.5. Give it a bit of girth to make sure it stays in place nicely. And I think I'll actually get rid of that. Because I think can I not adjust that point? Give that a bit of an angle so the printer doesn't have to print over nothing. It'll always have a bit of support to it, so you should get a better printing finish. So I'll go there, I'll print up from there, build up, build up, build up, build up, build up. That's all supported. That's there. We'll do another sweep down to, oh boy, down to there-ish. You, can we make you tangent? That's not the tangent I want. Can I make you tangent? There we go. You, now will you tangent? You will not tangent. That's fine. You, that looks good. Connect those. Okay. Trim you. And connect you. Print that out. Features, how wide do I have to go? Cancel you. How wide? We're just going to want to make it as wide as this is. Measure 15.3. Chat, no chat. Boop. So if we go extrude boss space blind 15.3 divided by 2. It is so handy you can just put math into dimension. Saves so much time. 15.3 divided by 2 both ways. And now we have that. So servo connects into there. We'll have the GoPro connect onto there. Might not even need to cut it. Might be fine just as is. Let's see if we can evaluate. So you want minimum distance between that circle and that face. And then at 5 millimeters distance-wise. If I can get a nice angle. So yeah. Measure again. Minimum distance from you to you. See, we got the 5 millimeter minimum distance. This piece is going to be 3.75 in diameter, and so we'll have a nice little gap of, what is that, 1.25 millimeter, which is going to be a little tight, but it's not going to be touching, so that is fine. So that is good. We will then, I guess we'll have to create a new reference geometry. We will do reference to you and reference to you. We want you to be parallel, perpendicular. Surprised it's happy with that face. I figured I might want to go that face as well, but that's fine. Sketch. As far as the shape, it was this cut extrude. So outside ones 3 mil, 3 mil, and then 1.65 to the middle. So I'll draw that out, I guess. You to you to you to you to you to you to you. It looks ugly, but it'll work. Measure 1.65 to the middle. Actually, let's just trim these and just mirror it. Measure, I want you to be 3 mil. Evaluate measure. That is 3 mil. Perfect. 3 mil there, 3 mil there. Let me drink some water before my voice totally goes. Right. Mirror entities. We want to mirror you, you. I guess we don't need you. You, you. Mirror you about you. Connect you up top. You do not connect. You connect. Extruded cut. Before we do that, I want to measure this. I guess we can do you to that line. So that line is the center point. The circle is 15 mil wide, so it'll be 7.5 to the bottom connecting circle. Let's do 9 to give it space. And that'll be nicely in plane with that, almost like I planned it. And extruded cut. We will through all both, not through all both. We'll go through all in one direction. Can you update? Second direction, we'll go up to surface U. Okay. So now GoPro will slot through there. Hold it in place. It can press up against the servo. That'll print like that. That'll print up to there. Those might be printable without support, but that will not. And those will not as well. So I'll have to clear that sort of support, clear that support. I'll have to see if I can get fancy enough to clear this with support. Those look nice and smooth. Perfect. Actually, instead of just measuring it, let's actually, you are going to be collinear with you. And now that'll be perfectly in line, just to make sure. GoPro sits there, gear sits there, gear sits there. Pivot, pivot. All right. Sketch on those planes, but section it according to that face. So you can see what I'm doing. Just want to cut an octagon square. I guess a square will be an easy thing to cut for these. Simple little square. This one's not going to have a whole lot of play to it. So that's only 7.5 wide. Enough wide. Could bend this arm around there. So it's gonna be an arm coming out here. We could just have a little notch in it, but that's gonna look goofy. So let's not do that. And so square notch to there. Bolt's gonna need to fit through there. That wants to sit in there. Slot's bigger than the bolt, but smaller than the total circle. Okay. I want to make those bigger. It's fine, because these are what? Let me click on it. Those are 4.5 wide. Sketch. If we make you maybe 7.5. It's not going to leave a whole lot of room to play around with stuff. That's fine. So I'll work on these ones just fine, because that'll be a big circle that I can go through. These ones, put a slot all the way through, then just clamp it tight. Should be fine, but then still putting a slot all the way through with the thick bolt. Do I just go down to the really small bolt then? That might be what we have to do. Yeah. I guess that's what will have to be done. I was hoping I could use the same big bolts for the front and the back. I just have some, I don't even know what size these are, but they're like 4 millimeters across thread, so kind of chunky. But instead I'll use some, I ended up buying some specific bolts. No chat, cool. Ended up buying some specific bolts, change assembly, because I needed some very small bolts to fit in these holes. So those are only, I want to say they're 3 millimeters across, which I can tell you. Those holes are, yeah, 3 millimeter across. So I need a really tiny bolt. And so I got some M2 bolts off of Amazon. It was either buy them at the store for 5 for $5, or buy them off of Amazon for 300 for 20 bucks. Bit of a hard sell on that one. So ended up buying the bolts, and I got a ton of very tiny bolts, which a lot of them are gonna be kind of useless because they're only like 4 millimeters long, and I'm not quite sure where I'll use those, but the longer ones I will probably use a fair bit for very finicky small parts, like the section right here. So let's see, that'll be the inner size of it. Let's make an outer circle. This outer circle will need to be bigger than the head of the bolt it will be supporting. Head of the bolt is a little under 7 millimeters wide. So I guess let's go 8 millimeters wide for that. We don't want this actually here. Construction. We want to set coincident. And then we want these to be equal, so we have a nice square. So yeah, we're going to cut this square into this bottom base plate. We'll then cut an 8 millimeter wide hole through the gear. And then we'll need to cut a secondary lip on it. So we'll make kind of a T-shape piece of plastic that sits in here. Then the gear will be around it. And once you put the bolt in, it rests on the secondary piece, which locks into here, so it won't screw or unscrew. So I will keep the gear in place, but it won't be threatened by the turning of the gear. It's not going to accidentally loosen itself in time. So we can get rid of you again. We'll just mirror. Keep using the wrong delete button. Then that's all I need for there. As far as this one goes, I think these screws are like 2 millimeters across. Very tiny, very cute little things. Let's see. Honestly, kind of hard to hold in. Yeah, 1.92 is the distance across the threads. So I guess we'll make 3 millimeter wide circle. No. So the circle has to be bigger than the head of the threads. Head of the threads is 3.85. So let's do a 4 millimeter wide circle for construction. And you are 4 millimeters. Good. We'll have to readjust that one, but that'll come later. You will be coincident. You will be not parallel, equal. You'll be a square. So we'll cut this well, I guess it's not a 4 millimeter wide square. We'll cut the square in, and again, it'll sit everything in place and lock everything in. We'll go back, delete you, mirror entities. You want to mirror all of you. Mirror about that. And extrude cut. Through all, we'll go up to surface. Except we don't want up to surface. We only want like a blind cut. Go like 2 millimeters deep. 2 millimeters deep. And this side didn't want to go. Oh, because you are the inside. That's fine. Okay. Now back to boss extrude 2. This hole here. it will be, I guess, 2mm. We'll do 2.5 to give it some wiggle room. Exit sketch. So now we have the squares to lock into it, holes for the bolts to go through. All be easy to access on the top. So we'll make the bottom where we actually put the nuts for the bolts. Do I want to just screw into it? That might be worth it. Just say no. Oh. No to requiring a secondary nut. I just screw directly into the plastic. Am I going to be taking these out very often? Shouldn't be. Yeah, I got more nuts than bolts, so let's put nuts in. Printing up from the base plate. So we'll cut the slots through there. Display style, sketch. This face. Little rectangle. You need to be the center view. Okay. Center view, you are coincident. Excuse me. Can I just cut let's actually just cut a octagon on the bottom, which should be able to be supported. I could just do a square. I like squares. An octagon will look much cleaner. Polygon. We want it like that. You and you are going to be horizontal. Can I rotate? Nope. Cool. Let's measure the size of the old nut. Go flat faces to get an accurate reading. I'll lose the nut into my chair on the floor. I'll just grab another one. 7.9, 7.91, 7.89, 7.92. So I'll go like distance from that side to that side. We'll go 8.25. So it won't be a completely snug fit, but it should be snug enough and will give us play in case I'd rather have it be a little too loose than a little too tight, because a little too tight is a pain in the butt to get to work. Which I guess could sand stuff down. Yeah, if it's too loose, then it's just not going to work. Yeah, we'll go 8, which will be should be borderline too tight, but should be fine with any luck. You and you, horizontal. You and you. How big are these small nuts again? Do a quick chat check. No chat. I think I'll see about getting a second monitor eventually, maybe. Because it definitely seems like it'd be very helpful to have. So you are 3.9 across. And 3.9. Do it to 4, we'll have a grand total of 0.1 millimeter again. Should be fine. Again, it'll be very tight, but should work. Sketch. Mirror. We want to mirror both of these across that plane. And we want to extrude a cut. Go blind. Far up do you want to go? So we'll go 5 millimeters. Let's set those way in. 3 millimeter of material in between. Actually, I'll have to make sure these are long enough for this bottom section here. So I have some longer bolts in the bigger size, but these bottom ones, the longest I have, are 12 mil. Which, actually, if our arm is only 5 mil thick, should give us room. Let's see, 10 mil of thread. Keep it flush, it's 12 mil. Should be good. So yeah, 5 mil up. Lock that in place. Yeah, 3 mil thick at the bottom, 2 mil at the top. Lock that in. That goes there. 5 mil there, 5 mil at the bottom to play with. We have 2 mil down, and then the bolt, 3 mil of extra room. Should be good. Now look up there of big enough bolts for that, I'm sure. That'll there. Let's lock into there. Let's pretty up this shape a bit. So cut that like that. I think. Let's see. U to U. Evaluate measure. That distance. Looking at 7 mil. Go from U to U. Please don't break everything. Nice. 7 to there. Sketch. Get rid of those points. Put a nice fillet. Keep that nice and smooth. Then extend that over to there. And now it's not happy. You edit sketch. Figured it so. You edit that line. Happy? Cool. So we got that. Servo in there, gear bottom, GoPro there. That. Those lock into there, that lock into there. Do I want to put a fillet there? Is that there? That's way too big. 5 mil. How'd that look? That looks good. Let's lock into there, let's lock into there. Smooth enough. Do I want to smooth out that curve? I don't think we do. I think that's good. Nice and even. That's that. All right. I'd say that piece is good. And think I'm going to take lunch here. Didn't have much of a snack. I just had an apple when I took that snack break, so I'm feeling kind of hungry again. So I think I might end the stream there. And I guess I don't know why I'm talking to anyone. No one's even hearing this to join back up, but I'll be back in a bit once I've had some lunch. And I'll get on to working on the gears and working on the arms, and then with that done, that should be base this robot. I'll have to remake that prop, and then should be ready to do a little bit of stress testing. I'll see if I head on to that tonight or leave that for the next time. And anyways, thank you for watching. See you in the next one.